So extra problem, P1 and P2 are two particles moving in rectilinear motion. The curves shown in document 1 and document 2 represent the change of particles, vehicles versus time. Referring to document 1, which is associated to P1, identify its nature. Identify means you have to give the answer and justify it. So it's uniformly rectilinear motion. Uniform because V is constant, because V versus T is a horizontal line showing constant speed. And rectilinear because you are given that the motion is rectilinear, or you may be given like the object moving along a straight line, so this would be the justification for rectilinear. Part B, calculate its acceleration. When this is given, this means that you have to calculate the average acceleration within the range given here from 0 to 8 seconds. So A average is equal to delta V over delta T, which is V final for the interval of time given minus V initial over T final minus T initial. It is equal to V final is 3.4. Why 3.4? Because we have 3 till 4. How many subdivisions are there? 1, 2, 3, 4, 5 subdivisions. So 1 divided by 5, each subdivision is equivalent to 0.2. 1 divided by 5 is 0.2. This is the value for one subdivision. So we have two subdivisions here above 3, so it's 3.4. 3.4 minus 3.4 meter per second over T final 8 minus 0 seconds. So it's 0 meter per second square, because 3.4 minus 3.4 is 0. You have to write the unit meter per second squared, even though the number is 0. Part C, given that when the time starts at t equals 0, P1 was at 4 meters from the origin, so you are given the initial position. Determine the position time equation of P1. Because it is URM, so the general equation is of position time is x equal Vt plus initial position. V is obtained graphically and x0 is given. So when we say it started moving 4 meters away from the origin, so if this was the origin, started moving from this point, I'm going to call it x0, such that x0 is 4 meters away from the origin. So x is equal to 3.4 t plus 4, and between parentheses you write SI units. Okay, so this is 3.4. This is the position time equation. Now plot the position time curve of P1. What shall you do? You shall take particular points, but within the range given here from 0 till 8 seconds. Do not exceed it, and do not draw till 5 only, for example, or till 4 only. So you have to draw a table. 3 particular points are enough. For example, you take T, and this is the corresponding X. 1, 2, 3 points. For T equals 0, for T equals 1, and for T equal 2. For T equals 0, X equal 4. For T equal 1, X equal 4 plus 3.4 is 7.4. For T equals 2, we substitute here for T and T. 2 times 3.4, we obtain 6.8 plus 4, 10.8. Okay, here in meters, because because this was already given in the SI unit, so we have to substitute T in the SI unit to obtain X in the SI unit. And then we take a scale. Take, for example, each 1 centimeter is equal to 1 meter. Okay, so you have to take a scale. Each 1 centimeter is equal to 1 meter. And just as given here on the x-axis, every 1 centimeter is equal to